Hi, buddy. Today we're going to talk a little bit more about the t-test, going to introduce the concept a little more clearly today. We'll get into the math later and all of that stuff, but just want to get at the idea here for a t-test and especially contrast it more with the correlation. So once again, a correlation looks at how the value of one variable seems to be associated with the value of a second variable as long as we've got paired observations. A mean comparison, however, has at least two different groups, and there are lots of ways to form these groups and lots of ways to do that. We'll cover that later. But then it assesses whether those two groups differ in their average on some other variable that you measured on both. So I'll give you a solid example here in a minute to describe more of what we're doing. Now, a t-test is interested in determining whether those groups' means are different from each other. Not only that, but also different enough from each other that we can start to kind of get excited about it. Because if they are different from each other enough that we can get excited about it, that suggests that perhaps the independent variable influenced the reason why those two scores are different. Okay, so I'll give you an example here in just a second, but one of these mean comparison tests is the t-test. There are different versions of the t-test that we don't need to worry about right now. We'll get into that in the future. There are other mean comparison tests as well. As I said, there's something called an ANOVA, and we'll get into all that. But I'm just going to give you a very basic idea of what one version of the t-test can look like today, so we have a nice idea of what this looks like. All right, so let's just imagine that we've got some cognitive test and we're interested in how caffeine versus sugar influences that cognitive test. Okay, so in other words, I want to give one group of people, let me back up. Let's say I want to randomly select people from, just a sample of people in the city or whatever, and I bring them in and then I randomly assign them to one of two groups. Some of the people in my sample will get caffeine and then they'll take a cognitive test. And then the other people will randomly assign to drink a sugary drink and take the same cognitive test. Then what I'm measuring them on is their cognitive test score. What I want to see here is, do people getting the caffeine have a different score on average than people getting the sugary drink? That's essentially what I'm doing. It's a very simple test, very simple experiment there as well. So here's one way to think about this visually. Let's say I do this and I record the cognitive test score of the caffeine group, and it looks something like this. Let's imagine that we have an average now of, let's say, 104. Okay, let's say that this is the average score of 104. Now, as you can see here, it's also, in some ways leptokurtic. So it's a fairly condensed group here. Now look at this. One of the reasons that we have this spread around here is that not everybody was the same in their cognitive abilities in the first place, right? That's all kinds of stuff. IQ, their genetics, their studying habits, all sorts of things like that. Their, how awake they were, generally. Things that I generally can't control. The only thing that I treated as differently was whether they were getting caffeine versus a sugary drink, right? So that's my variable. So all of this variation is caught in the standard deviation, right? Okay, just hang on to that for a second. Now, let's take a look at the distribution from the people who took the sugary drink. And let's say it looks something like this. Now, I'm just making this up, right? But so again, they had an average score of, let's call that 96, okay? Whereas the other group had an average of 104. Okay, now same thing here, however, is you got an average that's lower, right? So if I were to ask you the simple question, who scored higher, you would have to say it was the other group. You would have to say it's the caffeine group because an average of 104 is higher than an average of 96. However, what the t-test starts to be interested in, or is interested in, is this spread as well. Not only is it interested in those mean differences, but also the spread. So let's take a look at this by putting both distributions next to each other, and you'll start to get an idea of what the t-test does. Okay, so now if I put these two distributions together, it looks like this, right? I've got the green distribution, which is the caffeine group, the people who receive the caffeine before taking the cognitive test, and the blue group is the people who receive the sugary drink. Now, just a quick observation, you could say, well, who scored higher? Clearly it was the caffeine group, right? Because not only was the maximum score highest, but also on average, the definition right here of this average, assuming they were symmetrical distributions, is higher than that average. Okay, so are we all done here? It turns out the t-test says no, we're not necessarily done here, because simply having a higher mean doesn't mean that it's a meaningfully higher mean. What is important about that is the t-test looks at the spreads of these distributions and says, well, look, there is a lot of variability in the caffeine scores. As you can see, look at all that spread. So people were quite different in their cognitive test scores, regardless of whether they had the caffeine drink, right? They look at that spread and look, and same thing for the sugary drink. Look at how different people were. And it also looks at sort of this overlap. Look at how much these two groups overlapped in their scores. So in other words, this person, there were a lot of people in this range who took the caffeine drink, but they got the same score as people who got a sugary drink. So what the t-test says is, are these different enough given the spread of these distributions that I can actually say it looks like which drink they had influenced their cognitive test score. And it's a very sophisticated and interesting way in which it does that, which we will cover over the next few lectures, I'll call them, the next few lessons. But that's just a very brief introduction of what the t-test is doing. Now, a couple of things you'll notice also. It does have to be a continuous measure that we're looking at, right? If it's not a continuous measure, if it's binary or ordinal data, we're probably using the wrong test. Also, t-tests usually have the independent variable is the grouping variable, right? So in other words, I assume that it's which kind of drink they had that influences their cognitive scores and not the other way around. That's generally how these t-tests work, although it's not like against the law or something to go the other way around. You'd have to very carefully think about it. So if you're not sure, talk to somebody who knows this kind of stuff. All right. Okay, so let's summarize what we just covered. Okay, so a mean comparison, the first mean comparison that we'll talk about is called the t-test, or sometimes you'll see it called the student's t-test. In my textbook, for example, I only ever refer to it as the t-test. There are different versions of the t-test. We will talk about that next in the next lesson. Normally we have one dichotomous grouping variable that is the independent variable, and we have a continuous dependent variable, as I just said on the last slide. And what the t-test does is mathematically assesses essentially the ratio of the mean difference to the standard deviations, the pooled standard deviations. It's a little bit more complex than that, but that's basically the idea. If you think back to that idea of in the numerator, we have the variance we can account for, and in the denominator, we have the variance that we can't account for, right, that we had no control over. And we look at that ratio. That's essentially what the t-test looks at as well. Now we'll cover that more when we get to the math portion of that. And as I said, there are different kinds of t-tests, and we'll cover that next. That'll be the next thing. There are some that have samples that should be related to each other and affect each other, and there are other designs that shouldn't affect each other. And there's also an interesting design which uses only one sample and compares it to some criterion that the researcher sets. So we will pause right there and get back to this in due course. I'll see you then.